What if I told you that right beneath your feet, hidden under miles of water, exists a world so alien, so mysterious, and so terrifying that we know more about the surface of Mars than we do about this place? What if the deepest parts of our own planet hold creatures so bizarre they seem pulled from nightmares, sounds so strange they defy explanation, and ecosystems so extreme they challenge everything we thought we knew about life itself? If you enjoyed this mind-bending thought, hit that like button. Also, 99% of you that watch our videos are here to subscribe. So kindly hit the subscribe button. It helps our video reach more people who enjoy content like this. Welcome to the Uncharted Abyss, the deep ocean, Earth's final frontier. Today we're diving into the darkest, most mysterious, and most terrifying realm on our planet. And I promise you, by the end of this journey, you'll never look at the ocean the same way again. Right now, as you're sitting here, more than 70% of Earth's surface is covered by ocean. But here's what will blow your mind. We've only explored about 5% of it. 5%. That means 95% of our planet's ocean floor remains completely unknown, unmapped, and unexplored. Dr. Jean Carl Feldman from NASA's Ocean Biology Processing Group puts it this way: we've done a better job exploring outer space than exploring our own ocean. Think about that for a second. We've sent robots to Mars, landed probes on distant comets, and mapped the surfaces of planets billions of miles away. But the deepest parts of our own ocean? They're still complete mysteries. And these aren't just empty wastelands of water. Recent expeditions in 2025 have revealed something extraordinary. Scientists exploring the Mariana Trench, the deepest place on Earth, have discovered thriving ecosystems nearly 10 kilometers below the surface. Animal communities, including thousands of tube worms and bivalves, have been found at depths reaching 9,533 meters, marking the deepest and most extensive chemosynthesis-based ecosystems ever known. But before we dive into the incredible creatures and mysteries of the deep, you need to understand just how impossibly hostile this environment really is. Imagine standing at the edge of the Mariana Trench, looking down into the abyss. The trench stretches over 1,580 miles long and plunges to depths of nearly 11 kilometers. That's almost 36,000 feet down. If you dropped Mount Everest into the Mariana Trench, the peak would still be more than a mile underwater. But the depth isn't even the most terrifying part. It's what that depth does to everything around it. At the surface of the ocean, the pressure is normal, about 14.7 pounds per square inch, the same pressure you experience right now. But as you descend, something incredible and terrifying happens. For every 33 feet you go down, the pressure increases by 1 atmosphere. By the time you reach the deepest part of the Mariana Trench, the pressure has increased to more than 1,000 atmospheres. That's over 16,000 pounds per square inch, the equivalent of having 50 jumbo jets stacked on top of every square inch of your body. Dr. James Cameron, the filmmaker who made a solo descent to the Challenger Deep in 2012, described the experience this way: the pressure down there is so intense that if there was even the tiniest leak in the submersible, the water would come through like a laser beam and cut you in half instantly. Think about that. A tiny leak, smaller than a pinhole, would turn water into a cutting tool more powerful than any saw. The pressure is so extreme that it would literally compress your body into something the size of a small marble. But here's where it gets absolutely mind-blowing. Despite this crushing pressure, despite the complete darkness, despite temperatures just above freezing, life doesn't just exist down there. it thrives. And I'm not talking about simple bacteria. I'm talking about complex creatures, fish, squid, crustaceans, and organisms so bizarre that when scientists first discovered them, they thought they were looking at aliens. But to understand these creatures, we need to understand the different zones of the ocean, because as you descend, you're essentially traveling through different worlds, each one more alien than the last. The ocean is divided into 5 main zones, and each one gets progressively darker, colder, and more extreme. The first zone is the sunlight zone, or epipelagic zone, which extends from the surface down to about 200 meters. This is where most marine life lives, where sunlight penetrates, where photosynthesis happens, where the water is warm and life is abundant. This is the ocean you think you know, the one you see in documentaries, the one you might have swum in. But once you drop below 200 meters, you enter the twilight zone, or mesopelagic zone. Here, sunlight begins to fade rapidly. The deeper you go, the dimmer it gets, until the only light comes from the creatures themselves, glowing, pulsing, shimmering with their own bioluminescent light. This zone extends down to about 1,000 meters, and it's here that things start getting really weird. The pressure is intense, the temperature drops dramatically, and the creatures that live here have evolved incredible adaptations just to survive. But the twilight zone is just the beginning. Drop below 1,000 meters and you enter the midnight zone, or bathypelagic zone. Here, sunlight has completely vanished. It's not just dark, it's a darkness so absolute, so complete, that if you were there without artificial light, you literally couldn't see your hand in front of your face even if you held it right up to your eyes. The temperature here hovers just above freezing, around 4 degrees Celsius. The pressure is crushing, hundreds of atmospheres pressing down on everything. And yet, life persists. Strange, alien, beautiful life that is adapted to conditions that would instantly kill almost any surface creature. And the midnight zone is just the beginning. Drop below 1,000 meters, and then we enter true alien territory. The abyssal zone stretches from 4,000 meters down to about 6,000 meters. This is the realm of the true deep sea, a world of endless midnight, crushing pressure, and temperatures just above freezing. The seafloor here is covered in sediment that has been drifting down from the surface for millions of years, the remains of dead organisms slowly settling like cosmic snow. But even here, in the seemingly inhospitable environment, life has found a way. Creatures have evolved to live with almost no food, in complete darkness, under pressure that would crush a human instantly. And then, if you dare to go even deeper, you reach the final zone, the Hadal zone. This is the zone of the deepest ocean trenches, extending from 6,000 meters all the way down to the deepest point on Earth at nearly 11,000 meters. The Hadal zone is named after Hades, the ancient Greek god of the underworld. And trust me, that name is absolutely appropriate. Recent scientific research published in the journal Cell in March of 2025 has revealed something extraordinary about the Hadal zone. Despite the extreme conditions, pressure exceeding 1,000 atmospheres, complete darkness, near freezing temperatures, and virtually no food raining down from above, biodiversity here is not just present, it's extensive and flourishing. But what kind of creatures could possibly survive in such an extreme environment? What kind of adaptations would be necessary to live under 1,000 times the pressure you experience right now, in complete darkness, with almost no food? The answers will blow your mind. Let's start with pressure adaptation, because this is absolutely fascinating. You see, most creatures, including humans, would be instantly crushed at these depths because we have air spaces in our bodies. We have lungs filled with air, sinuses in our heads, air in our ears. Under extreme pressure, these air spaces would collapse instantly, crushing us from the inside out. But deep-sea creatures have evolved to eliminate air spaces almost entirely. Many deep-sea fish don't have swim bladders, the gas-filled organs that help surface fish control their buoyancy. Instead, they have bodies that are mostly water and gelatinous tissue, which are virtually incompressible. Some deep-sea fish are so gelatinous, so jelly-like, that if you brought them to the surface, they would literally fall apart. Their bodies are only held together by the immense pressure of the deep ocean. Dr. Rick,
bioluminescent glow from other creatures kilometers away. Other creatures have abandoned vision entirely and developed other senses. Some fish have elaborate systems of sensors running along their bodies that can detect the tiniest vibrations in the water, feeling the movement of prey or predators through pressure waves. Still others have evolved chemical sensors so sensitive they can taste a single molecule of food in billions of molecules of water, following scent trails to find meals in the endless dark. But perhaps the most incredible adaptation is bioluminescence, the ability to create light through chemical reactions in their own bodies. Bioluminescence is everywhere in the deep ocean. It's estimated that up to 90% of deep-sea creatures can produce their own light, but they don't use it the way we use light. They've turned light into a weapon, a lure, a communication system, and even a form of camouflage. Let me explain how absolutely incredible this is. Some deep-sea fish have evolved photophores, specialized light-producing organs on their bellies. They use these lights for what's called counter-illumination. By producing light on their undersides, they match the faint glow filtering down from above, making themselves invisible to predators looking up from below. It's like having an active camouflage system built into your body. Other creatures use bioluminescence as a lure. The famous anglerfish has a glowing appendage that dangles in front of its mouth like a fishing rod. In the pitch darkness, other creatures see this glowing light and swim toward it, thinking it might be food or a mate. But when they get close enough, snap! The anglerfish's enormous jaws close around them. Still others use bioluminescence for communication. Some squid species can create complex patterns of light across their bodies like living billboards, communicating with potential mates or warning off rivals. And some creatures have weaponized bioluminescence in ways that seem almost intelligent. Certain deep-sea shrimp can shoot out clouds of glowing chemicals when threatened, creating a luminous smoke screen that blinds and confuses predators while the shrimp escapes into the darkness. But perhaps the most incredible example of bioluminescence comes from a creature that was only recently filmed alive in its natural habitat for the first time in 2025. The colossal squid. The colossal squid is one of the largest invertebrates on Earth, potentially reaching lengths of up to 14 meters. That's about 46 feet long. For perspective, that's longer than a school bus. This creature has the largest eyes in the animal kingdom, each eye the size of a dinner plate, designed to capture every available photon in the dark depths. But here's what makes the colossal squid truly extraordinary. It has the largest known biological light-producing organs in any living creature. Each squid has enormous photophores that can glow with an eerie, otherworldly light. Scientists recently captured footage of what they're calling the octopus squid, a related species, revealing bioluminescent organs so large and powerful they look like glowing green searchlights. Dr. Bruce Robeson from the Monterey Bay Aquarium Research Institute, who has studied bioluminescent squid for decades, describes it this way. When these squid activate their photophores, it's like they're turning on stadium lights in the deep ocean. The amount of light they can produce is absolutely staggering. Research published in 2020 revealed something even more incredible. Scientists discovered that humboldt squid use their bioluminescence not just for attracting prey or avoiding predators, but for complex communication. They can create sophisticated patterns of light across their bodies like a living light show to communicate with other squid in the darkness. Imagine that for a moment. In the pitch-black abyss, squid are having conversations using light, creating patterns and signals that convey complex information to other members of their species. It's like they've evolved their own language of light. But the colossal squid is just one example of the incredible creatures lurking in the deep. Let me tell you about some others that are so bizarre, so alien, that when scientists first discovered them, they could barely believe they were real. There's the bear-eye fish, a creature so strange it looks like something from science fiction. This fish has a transparent head. You can literally see through its skull to its brain inside. Its eyes are tubes pointing upward, constantly scanning the water above for the silhouettes of prey. When it spots something, it rotates its eyes forward to focus on the target. A fish with a see-through head and rotating eyes. Let that sink in. Then there's the gulper eel, also called the pelican eel because of its enormous mouth. This creature's mouth is so big that it can open wide enough to swallow prey larger than itself. Its jaw unhinges like a snake's, and its stomach expands like a balloon to accommodate huge meals. In the deep ocean where food is scarce, the ability to eat anything you encounter, regardless of size, is a crucial adaptation. Or consider the vampire squid, a creature so bizarre it has its own unique taxonomic order. Despite its terrifying name, the vampire squid is actually quite small and harmless, but its appearance is nightmarish. It has a dark reddish-black body covered with light-producing photophores, and when threatened, it can turn itself inside out, wrapping its webbed arms over its body like a cloak. When it does this, it releases a cloud of bioluminescent mucus, a glowing sticky substance that blinds and confuses predators, while the vampire squid escapes into the darkness. And then there are the extremophiles, organisms that don't just survive in extreme conditions, but actually require them to live. In 1977, scientists made one of the most shocking discoveries in the history of marine biology. While exploring the Galapagos Rift using the submersible Alvin, they discovered something that shouldn't have been possible: thriving ecosystems surrounding hydrothermal vents on the ocean floor. Hydrothermal vents, also called black smokers, form where seawater seeps down through cracks in the ocean floor, gets heated by magma beneath the Earth's crust, and then erupts back up in superheated plumes. The water coming out of these vents can reach temperatures of 400 degrees Celsius, hot enough to melt lead. Scientists expected these areas to be completely lifeless. The water is toxic, filled with heavy metals and sulfur compounds. The temperature fluctuates wildly. The pressure is crushing. By all logic, nothing should be able to survive there. But they were wrong. Incredibly, spectacularly wrong. Surrounding these vents, scientists found enormous communities of life. Giant tube worms up to 8 feet tall, massive clams, strange crabs, and bacteria unlike anything seen before. These weren't just surviving, they were thriving in conditions that would instantly kill almost any other life form on Earth. And here's the truly mind-blowing part. These ecosystems don't rely on the sun at all. Instead of photosynthesis, converting sunlight into energy, which is the basis of almost all life on Earth, they use chemosynthesis, converting the chemicals in the vent water into energy. The bacteria living near the vents absorb sulfur compounds and other chemicals, using them to create energy. The tube worms don't even have mouths or digestive systems. They have billions of these chemosynthetic bacteria living inside their bodies, producing all the nutrients they need. Dr. Robert Ballard, who discovered the Titanic and has made dozens of deep-sea discoveries, calls hydrothermal vents the most important biological discovery of the 20th century. He explains it this way: finding these ecosystems completely changed our understanding of what life needs to survive. If life can exist there, using chemistry instead of sunlight, then life might be possible in places we never imagined, beneath the ice of Europa, in the liquid methane lakes of Titan, or deep under the surface of Mars. And scientists keep discovering more. In recent years, they found similar communities around cold seeps, places where methane and other hydrocarbons leak out of the seafloor. These ecosystems are also based on chemosynthesis, but use methane instead of sulfur. These discoveries have profound implications not just for marine biology, but for our understanding of life itself and our search for life elsewhere in the universe. But as incredible as these creatures are, they're not the strangest things we've found in the deep ocean, because down there, in the darkness and pressure of the abyss, we've detected things that we still can't explain. Mysterious sounds, strange geological formations, and unexplained phenomena that continue to puzzle scientists. Let me tell you about some of the most mysterious and disturbing discoveries from the deep. In 2016, researchers detected a strange, persistent sound coming from the Mariana Trench, a metallic, almost mechanical ping or boing that repeated regularly but had no obvious source. Local fishermen in the area reported that the sound was driving fish away from the region. Scientists from various institutions investigated, deploying listening devices and studying recordings of the sound. But here's the disturbing part. They still don't know what's making it. Theories range from baleen whales producing previously unknown vocalizations, to ships using unknown sonar systems, to geological activity in the trench itself. But nobody knows for certain. And this isn't the first mysterious sound from the deep. Over the years, underwater microphones have picked up numerous unexplained sounds from the ocean depths. There was the bloop, an ultra-low frequency sound detected in 1997 that was loud enough to be heard on sensors more than 5,000 kilometers apart. The sound had a pattern that suggested a living creature, but it was far too loud to be produced by any known animal. Scientists eventually determined it was probably the sound of icebergs fracturing and cracking, but for years it remained a complete mystery. Then there's the upsweep, a continuous sound that has been detected since 1991. It rises and falls in frequency, almost like a living heartbeat, but nobody knows what's producing it. The sound has been getting progressively louder over the years, which makes it even more mysterious. These unexplained sounds remind us that the deep ocean still holds secrets we haven't begun to understand. But it's not just sounds that are mysterious. The deep ocean floor itself contains geological features that challenge our understanding of how planets work. Hydrothermal vents, which we talked about earlier, are fascinating enough on their own. But scientists have discovered vents that behave in completely unexpected ways. Some vents, called white smokers, emit water that's cooler and contains different chemicals than black smokers. Scientists are still figuring out how these different vent systems work and what implications they might have. Even more mysterious are mud volcanoes, enormous structures on the seafloor that can be hundreds of meters tall, constantly oozing mud and gas from deep within the Earth's crust. Recent expeditions to the Mariana region in 2025 have revealed that this area contains the largest mud volcanoes on Earth, some of them completely unexplored. What's inside these mud volcanoes? What kind of life might exist in the unusual chemistry they create? Scientists are just beginning to investigate, but initial findings suggest these structures might host unique ecosystems found nowhere else on Earth. And then there are the uncharted trenches and canyons that we're still discovering. The ocean is so vast and so deep that we're still finding new undersea mountains, canyons, and trenches that were completely unknown until recently. In 2020, scientists announced the discovery of what might be the deepest point in the Southern Ocean, a trench that could rival the Mariana Trench in depth. We simply don't know because we haven't been able to explore it yet. What creatures might live there? What mysteries might it hold? Every new trench we discover is like finding a new continent, a vast, unexplored realm that could contain species, ecosystems, and phenomena that we've never seen before. But exploring these incredible depths requires technology that pushes the absolute limits of human engineering. Because remember, the deep ocean is one of the most hostile environments in the known universe, more extreme in many ways than the surface of Mars or the vacuum of space. Let me tell you about the incredible machines we've built to explore the abyss and the brave people who risk their lives to dive into the darkness. Deep-sea exploration began in 1960 when two men, Jacques Piccard and Don Walsh, descended to the bottom of the Challenger Deep in a submersible called the Trieste. The Trieste was essentially a steel ball attached to a giant tank of gasoline for buoyancy. The walls of the sphere were 7 inches thick, necessary to withstand the crushing pressure. Piccard and Walsh spent 20 minutes on the ocean floor, looking out through a tiny window at an alien world no human had ever seen. They saw strange fish and shrimp moving across the seafloor, proof that life could exist even at the deepest point on Earth. But that dive was just the beginning. Since then, we've developed increasingly sophisticated submersibles capable of exploring the deep. James Cameron's Deep-Sea Challenger, which he used for his 2012 dive to the Challenger Deep, was a marvel of engineering. The submersible was designed like a vertical torpedo to move efficiently through the water. It was equipped with LED lights, 3D cameras, and robotic arms for collecting samples. The pilot sphere, where Cameron sat during the dive, was only 43 inches in diameter, barely large enough to sit in, with walls designed to withstand over 1,000 atmospheres of pressure. Cameron described the descent as one of the most isolated experiences imaginable. It took over 2 hours to sink to the bottom, and during that time, he was completely alone, knowing that if anything went wrong, rescue was impossible. The pressure was so great that even a tiny leak would have been instantly fatal. But manned submersibles are just one way we explore the deep. Increasingly, scientists are using remotely operated vehicles, ROVs, to explore depths that are too dangerous for humans. Modern ROVs, like the one used by NOAA Ocean Exploration, called Hercules, are incredible pieces of technology. They're equipped with high-definition cameras, manipulator arms that can delicately collect samples, sensors that measure temperature, chemical composition, and pressure, and lights powerful enough to illuminate the darkness of the abyss. These ROVs are connected to surface ships by long tethers that provide power and communication. Pilots on the surface can control the ROV in real time, exploring the seafloor and collecting samples while sitting safely on a ship. Recent expeditions in 2025 using the ROV Sebastian, operated by the Schmidt Ocean Institute, have made incredible discoveries. In January 2025, this ROV captured the first confirmed footage of a colossal squid in its natural habitat, a monumental achievement after more than 100 years since the species was first identified. The Schmidt Ocean Institute also streams live video from their ROV dives, allowing anyone with an internet connection to watch real-time exploration of never-before-seen deep-sea environments. Thousands of people tune in to watch these dives, seeing bizarre creatures and landscapes as they're discovered for the first time. But even with all this technology, deep-sea exploration takes a toll on the people who do it. Dr. Robert Ballard, who has led hundreds of deep-sea expeditions, talks about the psychological challenges of exploring the abyss. He describes the constant tension between excitement at discovering something new and the ever-present awareness of danger. A small malfunction, a tiny leak, a broken tether, any of these could be catastrophic in the deep ocean, where rescue is impossible. Pilots of deep-sea submersibles undergo extensive training not just in operating the vehicles, but in managing stress and staying calm in emergency situations. They practice emergency procedures endlessly, knowing that in a real emergency, thousands of meters below the surface, there would be no second chances. And it's not just the immediate danger that weighs on deep-sea explorers. Many describe a profound sense of loneliness and isolation when descending into the abyss. The darkness is absolute, the silence complete, except for the occasional creak of the submersible's hull adjusting to pressure. You're more alone than almost any human has ever been, separated from the surface world by miles of water and pressure that could crush you instantly. But despite the dangers and the psychological toll, these explorers continued to dive, driven by the knowledge that every expedition reveals new wonders and new mysteries. And increasingly, it's not just professional scientists making discoveries in the deep ocean. A growing citizen science movement is allowing ordinary people to contribute to deep-sea research in fascinating ways. One of the most successful citizen science programs is called Seafloor Explorer, run by NOAA. This program uploads thousands of hours of seafloor video to the internet and asks volunteers to help identify creatures and features in the footage. Ordinary people, students, retirees, anyone with an internet connection can help scientists analyze data and make new discoveries. And it works. Citizen scientists have discovered new species, identified previously unknown behaviors in deep-sea creatures, and helped map unexplored regions of the seafloor. It's a powerful example of how modern technology allows everyone to participate in scientific exploration.
Ecosystems adapted to incredibly stable temperatures. The ocean also absorbs about a quarter of the carbon dioxide we emit. This CO2 dissolves in seawater and makes the ocean more acidic. Ocean acidification is affecting surface ecosystems, making it harder for corals and shellfish to build their calcium carbonate shells and skeletons. But acidification affects the deep ocean too. As acidic surface water sinks and mixes with deep water, it could affect the deep-sea creatures that use calcium carbonate. Things like deep-sea corals and certain plankton species that form the base of deep-sea food webs. And there's another concern that's even more worrying: changes to ocean circulation patterns around the globe, a system sometimes called the global conveyor belt. Cold, dense water sinks in the North Atlantic and near Antarctica, flowing along the ocean floor toward the equator. Meanwhile, warm surface water flows toward the poles, creating a continuous circulation that distributes heat. But as we explore deeper and learn more about the ocean's secrets, we face important questions about what we should do with this knowledge. Because the deep ocean isn't just a realm of scientific curiosity, it also contains resources that humanity might want to exploit. And this is where things get complicated and controversial. The deep ocean floor contains vast deposits of valuable minerals. There are fields of polymetallic nodules, potato-sized rocks containing manganese, nickel, cobalt, and rare earth elements. There are massive sulfide deposits near hydrothermal vents, rich in copper, gold, and silver. There are cobalt-rich crusts on underwater mountains. These minerals are essential for modern technology, for smartphones, electric car batteries, solar panels, and countless other products. And as land-based deposits become depleted, mining companies are looking to the deep ocean as the next source of these crucial materials. Several countries and companies have already secured exploration licenses from the International Seabed Authority to investigate deep-sea mining possibilities. Prototype mining machines have been tested in the deep ocean, and commercial mining could begin within the next few years. But here's the problem. We have no idea what the environmental impact of deep-sea mining would be. The deep-sea ecosystems we've discovered are incredibly fragile. Many deep-sea creatures grow extremely slowly. Some deep-sea corals can be thousands of years old. Recovery from disturbance takes not years or decades, but centuries or millennia. Mining operations would destroy the seafloor where they operate, creating massive plumes of sediment that could spread for hundreds of kilometers, smothering ecosystems far from the mining site. The noise from mining equipment could disrupt deep-sea creatures that rely on sound for communication and navigation. Dr. Lisa Levin, a marine biologist who has studied deep-sea ecosystems for decades, warns, "We're considering mining environments that we barely understand, destroying ecosystems that we've barely begun to study. Species that we haven't even discovered yet could be driven to extinction before we ever know they existed." But supporters of deep-sea mining argue that we need these minerals for the transition to renewable energy and electric vehicles. They point out that land-based mining often has severe environmental impacts too, and that deep-sea mining might be a necessary compromise. It's a difficult ethical question with no easy answers. How do we balance humanity's need for resources with the need to preserve unique and irreplaceable ecosystems? How do we make decisions about environments that we still don't fully understand? And deep-sea mining isn't the only threat to the ocean's depths. Climate change is affecting the deep ocean in ways that scientists are only beginning to understand. For decades, scientists thought the deep ocean was largely isolated from climate change. The thinking was that the deep ocean is so vast, so stable, that surface warming wouldn't affect it much. But recent research has shown that's wrong. The deep ocean is changing, and those changes could have profound impacts on the entire planet. The ocean absorbs about 90% of the excess heat from global warming. Most of that heat stays in the upper layers, but some is slowly working its way down into the deep ocean. Scientists are detecting temperature changes even in the deepest parts of the ocean, changes that might seem small but could have big impacts on creatures. The ocean has vast currents that circulate water, nutrients, and oxygen throughout the ocean. This circulation pattern is crucial for deep-sea life. It's what brings oxygen to the deep ocean, allowing life to exist in the abyss. Without it, the deep ocean would become largely lifeless, an anoxic dead zone like the Black Sea. But climate change is affecting this circulation. As ice melts in the Arctic and Antarctic, it adds fresh water to the ocean. Fresh water is less dense than salt water, so it doesn't sink as easily. This could weaken or even shut down parts of the global circulation system. Some climate models suggest that ocean circulation could slow by up to 40% by the end of this century. If that happens, the deep ocean could receive less oxygen, potentially leading to the expansion of oxygen minimum zones, regions where oxygen is so low that most animals can't survive. The impacts of such changes would extend far beyond the deep ocean. Changes in ocean circulation affect weather patterns, fisheries, and carbon dioxide absorption. A major slowdown in ocean circulation could trigger rapid and unpredictable climate changes worldwide. This is why understanding the deep ocean is so crucial. It's not just about satisfying scientific curiosity or finding cool new creatures. The deep ocean plays a fundamental role in regulating Earth's climate and supporting life on our planet. But despite these challenges and concerns, there's also incredible hope and excitement about what we might discover in the ocean's depths. Every expedition to the deep sea reveals new species, often dozens or even hundreds of new species on a single trip. Scientists estimate that there might be millions of species living in the deep ocean that we haven't discovered yet. Each of these species represents millions of years of evolution, solving the problems of survival in one of the most extreme environments on Earth. Studying them teaches us about the limits of life, the creativity of evolution, and the incredible diversity of ways that organisms can adapt and thrive. And there's practical benefits too. Deep-sea organisms have evolved unique biochemistry to survive in extreme conditions. Scientists studying extremophiles from hydrothermal vents have discovered enzymes that work at high temperatures and pressures, enzymes that are now used in industrial processes and medical research. The bioluminescent chemicals produced by deep-sea creatures are being studied for medical imaging applications. The antifreeze proteins produced by deep-sea fish could have applications in organ preservation. The unique compounds produced by deep-sea bacteria are being investigated as potential antibiotics and anti-cancer drugs. We've barely scratched the surface of what the deep ocean might teach us. Every new discovery opens up new possibilities, new questions, new avenues for research. And technology continues to advance, giving us better and better tools for exploring the abyss. The next generation of submersibles and ROVs will have better cameras, more sophisticated sensors, longer battery life, and greater autonomy. Some will use artificial intelligence to make decisions on their own, exploring the seafloor and identifying interesting features without constant human control. Scientists are developing new types of sensors that can detect specific chemicals or biological markers, helping us find new hydrothermal vents or locate creatures in the darkness. They're creating genetic sequencing equipment that can be deployed on the seafloor, analyzing environmental DNA to identify species without even seeing them. And there are plans for even more ambitious projects. Some scientists are proposing permanent research stations on the deep-sea floor, underwater laboratories where researchers could stay for weeks or months conducting long-term studies of deep-sea ecosystems. Others are developing new types of vehicles that could explore the deepest parts of ocean trenches, places that no human has ever visited and no camera has ever filmed. The Smith Ocean Institute's 2025 expeditions to the Mariana region are exploring areas that have never been visited before, using state-of-the-art ROVs equipped with the latest technology. Each dive brings new discoveries, new species, new behaviors, new mysteries to solve. And with live streaming technology, anyone can watch these discoveries happen in real time. You can sit in your home and watch as an ROV explores never-before-seen landscapes and encounters creatures that no human has ever seen before. It's an incredible democratization of exploration, allowing everyone to participate in the thrill of discovery. But perhaps the most profound thing about exploring the ocean's depths isn't what we find, it's what it teaches us about ourselves and our relationship with our planet. For thousands of years, humans thought the ocean was essentially bottomless, an infinite realm that we could never affect. We dumped our waste into it, overfished it, and treated it as an inexhaustible resource. But the more we explore the deep ocean, the more we realize how finite and fragile it really is.
The deep ocean isn't an alien world separate from us. It's intimately connected to everything that happens on the surface. The fish we eat spend part of their lives in the deep. The oxygen we breathe is partly produced by deep-sea processes. The climate we experience is regulated by deep ocean currents. And the impacts of human activity reach even to the deepest parts of the ocean. Scientists exploring the Mariana Trench have found plastic bags at the bottom, nearly 7 miles below the surface. They've detected radioactive contamination from nuclear tests conducted decades ago. They found evidence of chemical pollutants that were banned years ago but persist in the environment. Dr. Alan Jameson, who has led numerous expeditions to the deepest ocean trenches, describes finding pristine landscapes untouched by human presence, and then spotting a plastic bag or a piece of trash. A stark reminder that nowhere on Earth is truly beyond human influence anymore. This realization is both sobering and empowering.
It's sobering because it shows how far-reaching human impacts can be, but it's empowering because it means we have the power to make positive changes too. Every piece of plastic we prevent from entering the ocean, every ton of carbon dioxide we avoid emitting, every marine protected area we establish, all of these actions help protect the deep ocean and all the incredible life it contains. And protecting the deep ocean isn't just about preserving cool creatures and mysterious landscapes. It's about maintaining the health of the systems that keep our planet habitable. The deep ocean stores enormous amounts of carbon, helping to regulate atmospheric CO2 levels. It produces oxygen through bacterial photosynthesis. It moderates global temperatures through ocean circulation. It provides nutrients that support fisheries that feed billions of people. If we damage the deep ocean through mining, pollution, or climate change, we damage systems that are essential for human survival. But if we protect it, study it, and learn from it, we gain knowledge and resources that could benefit humanity for generations to come. This is why deep-sea research is so important, and why we need to support it even when it seems expensive or difficult. The money we spend on deep-sea exploration is an investment in understanding and protecting one of the most important and least understood parts of our planet. And we're at a crucial moment in history. We're developing the technology to really explore the deep ocean in detail, to understand its ecosystems and processes. But we're also facing pressure to exploit deep-sea resources and dealing with the impacts of climate change. The decisions we make in the next few decades will determine what happens to the deep ocean for centuries or millennia to come. Will we treat it as a resource to be extracted or as an ecosystem to be preserved? Will we rush ahead with deep-sea mining before we understand the impacts, or will we proceed cautiously, making sure we protect these irreplaceable environments? These aren't just questions for scientists and policymakers, they're questions for all of us, because the ocean belongs to everyone, and everyone has a stake in how it's managed. Let me tell you about some of the most exciting discoveries and expeditions that are happening right now, because the pace of discovery is accelerating, and every month brings new revelations about the deep ocean. In early 2025, scientists using advanced sonar mapping technology discovered what might be the largest underwater mountain range ever found, a chain of seamounts in the Pacific Ocean, some rising thousands of meters from the seafloor but still completely underwater. These seamounts create unique habitats that concentrate marine life, and they're likely home to thousands of species that exist nowhere else on Earth. Each seamount is like an isolated island, with its own unique community of species that evolved in isolation from other seamounts. Scientists are planning expeditions to explore these newly discovered mountains, and they expect to find hundreds or thousands of new species. Meanwhile, in the Arctic Ocean, researchers are discovering hydrothermal vents in regions that were previously covered by ice. As the Arctic warms and ice melts, it's revealing seafloor that hasn't been explored in modern times. These Arctic vents have their own unique communities of life adapted to the cold Arctic water combined with the heat from the vents, a unique combination found nowhere else on Earth. And in the Antarctic, scientists have made one of the strangest discoveries in recent years. Using hot water drills to bore through half a mile of ice, they lowered cameras into the ocean beneath the Ross Ice Shelf, a region that has been sealed beneath ice for potentially millions of years. They expected to find nothing, or at most a few simple organisms. Instead, they found complex life, strange creatures living in perpetual darkness, in water that's below freezing, sealed beneath a half mile of ice. How did they get there? What do they eat? How do they survive in such an extreme environment? Scientists are just beginning to unravel these mysteries. These discoveries are revolutionary because they show that life is even more adaptable, even more persistent, even more creative than we imagined. If life can thrive in these extreme environments on Earth, it dramatically increases the chances that life might exist in seemingly hostile environments elsewhere in our solar system or beyond. Jupiter's moon Europa has an ocean beneath its icy surface that might be similar to the ocean beneath Antarctic ice. Saturn's moon Enceladus shoots plumes of water into space from subsurface oceans. If life can exist in Earth's ice-covered oceans, maybe it can exist in these alien oceans too. The deep ocean isn't just teaching us about Earth, it's teaching us about the possibilities for life throughout the universe. But let's zoom back in on some specific creatures and phenomena that scientists have discovered recently, because the more we learn, the more bizarre and wonderful the deep ocean becomes. Scientists recently discovered what they're calling bone-eating zombie worms, strange creatures that live on the bones of dead whales that sink to the ocean floor. These worms don't have mouths or stomachs. Instead, they have root-like structures that penetrate into bones, and bacteria living inside them break down the bone material and provide nutrients. When a whale dies and sinks to the deep ocean floor, it creates what scientists call a whale fall, a concentrated source of food in an environment where food is incredibly scarce. A single whale carcass can support a complex ecosystem for decades, and it goes through distinct stages as different organisms consume different parts of the whale. First come the scavengers, sharks, hagfish, and crabs that tear away soft tissue. Then come organisms that consume the whale's bones and oil. And finally come the bone-eating worms and bacteria that slowly dissolve the skeleton itself over decades. Each whale fall is like a temporary oasis in the deep-sea desert, and scientists have discovered that some species only live on whale falls. They've evolved to specialize in this unique ephemeral habitat. Even stranger are the organisms that live in the sediments of the deep sea floor. Recent studies using advanced genetic analysis have revealed that these sediments contain possibly millions of species of bacteria and archaea, microscopic organisms that live in the tiny spaces between sediment grains, surviving on minute amounts of nutrients that drift down from the surface. Some of these microorganisms have metabolism so slow that they divide only once every 1,000 years or more. They're essentially living in slow motion, their biological processes running at speeds that seem almost impossibly slow to us. Yet they persist, generation after generation, in one of the most stable and unchanging environments on Earth. And then there are the mysterious purple orbs that scientists discovered in 2016 during an expedition near California. These orbs look like small purple spheres sitting on the seafloor, and when scientists collected one and examined it, they found it was a previously unknown species, possibly a new genus or even family of organism. The orb turned out to be a type of sea slug, but unlike any sea slug seen before. It's a reminder that even near heavily studied regions like California, the deep ocean still holds surprises. One of the most fascinating recent discoveries involves deep-sea coral reefs. Most people think of coral reefs as tropical, shallow water ecosystems bathed in sunlight, but deep-sea corals exist too, growing in the cold darkness thousands of meters below the surface. These deep-sea corals don't rely on photosynthetic algae like shallow water corals do. Instead, they capture tiny food particles drifting in the water. They grow incredibly slowly. Some deep-sea coral colonies are thousands of years old. Scientists have found corals that started growing before the Roman Empire and are still alive today. These deep-sea coral reefs create complex three-dimensional structures that provide habitat for hundreds of other species, fish, crustaceans, mollusks, and countless other organisms. They're like underwater cities in the deep, concentrating biodiversity in regions that would otherwise be relatively barren. But these coral reefs are incredibly fragile.
Bottom trawling, a fishing method that drags heavy nets across the seafloor, can destroy deep-sea coral reefs in seconds that took thousands of years to grow. Once destroyed, they may never recover within human timescales. This is why marine protected areas in the deep ocean are so crucial. By protecting regions of seafloor from destructive activities, we can preserve these ancient ecosystems for future generations to study and appreciate. And scientists are discovering that deep-sea ecosystems are connected in ways we never imagined. Recent research using genetic analysis and isotope tracking has revealed that nutrients and organisms move between different deep-sea environments, between hydrothermal vents and cold seeps, between seamounts and trenches, between whale falls and coral reefs. The deep ocean isn't a collection of isolated ecosystems. It's a vast, interconnected web of life, with species and nutrients moving between different habitats in complex patterns that we're only beginning to understand. This interconnectedness means that damage in one area can have ripple effects throughout the deep ocean. It also means that protecting key areas, like areas with high biodiversity or important breeding grounds, can benefit deep-sea life across wide regions. But perhaps the most exciting thing about deep-sea research right now is the development of new technologies that will let us explore more of the ocean than ever before. Scientists are developing autonomous underwater vehicles, AUVs, that can explore the ocean without human control. These vehicles can be programmed with specific missions: map this area of seafloor, follow this current, search for specific types of features, and then released to carry out those missions on their own. Some AUVs can operate for months at a time, covering thousands of kilometers and diving to depths that would be dangerous or impossible for manned submersibles. They collect data continuously, building up detailed maps and measurements of ocean conditions. Other scientists are developing new types of sensors that can detect specific chemicals or biological markers. These sensors can identify hydrothermal vents from kilometers away by detecting the chemicals they emit, or locate whale falls by sensing the unique bacterial communities they support. And there are efforts to create permanent research stations on the deep-sea floor, underwater laboratories where equipment can be left for months or years, continuously monitoring deep-sea environments and recording changes over time. These long-term monitoring stations are crucial for understanding how the deep ocean changes over time. Is it warming? Is it becoming more acidic? Are the ecosystems changing in response to climate change? Long-term data is essential for answering these questions. Some scientists are even proposing something that sounds like science fiction: underwater cities or research colonies where humans could live and work on the ocean floor for extended periods. While this is still far in the future, the technology to build such facilities is gradually being developed. Living underwater for extended periods would give scientists unprecedented opportunities to study deep-sea life and processes. Instead of brief visits and submersibles, researchers could conduct long-term observations, experiments, and studies that are impossible with current technology. And the data we're collecting is being used in increasingly sophisticated ways. Scientists are using artificial intelligence and machine learning to analyze thousands of hours of seafloor video, automatically identifying and cataloging species, counting populations, and detecting changes in ecosystems. This automated analysis is incredibly powerful because the amount of data we're collecting from the deep ocean is enormous, far more than human researchers could analyze manually. AI can process this data quickly, identifying patterns and anomalies that might take human researchers years to find. But AI has limitations too. It can only identify what it's been trained to recognize. New, unusual, or unexpected organisms might be missed by automated systems. That's why human observers are still crucial. We have the ability to recognize that something is unusual or interesting, even if we've never seen it before. This is where citizen science becomes so valuable. By having many eyes reviewing seafloor footage, we increase the chances of spotting unusual or rare organisms. And ordinary people often bring fresh perspectives that professional scientists might miss. There have been cases where citizen scientists have discovered species that professional researchers overlooked or identified behaviors that nobody had noticed before. It's a powerful reminder that everyone can contribute to scientific discovery. Speaking of discoveries, let me tell you about one of the most bizarre and controversial mysteries of the deep ocean: the possible existence of enormous, unknown creatures lurking in the abyss. Throughout history, sailors have reported seeing massive sea creatures, things that don't match any known species. Giant squid were once considered myths until specimens were finally captured in the late 1800s. Colossal squid were theoretical until the first specimen was found in 1925. So could there be other massive creatures in the deep ocean that we haven't discovered yet? Scientists debate this question intensely. On one hand, the deep ocean is vast and largely unexplored. Large creatures could certainly exist in regions we haven't visited. The colossal squid itself wasn't filmed alive in its natural habitat until 2025, more than a century after its discovery. On the other hand, large creatures need substantial amounts of food, and food is scarce in the deep ocean. The largest deep-sea creatures we know about, like colossal squid and giant isopods, are already near the theoretical upper size limit for animals in those environments. But here's where it gets interesting. Scientists have detected evidence of very large animals in the deep ocean without actually seeing them. They found enormous bite marks on whales and squid that don't match any known predator. They've detected sounds that suggest very large animals, though identifying what's making those sounds is difficult. And the deep ocean has plenty of hiding places. There are vast regions of seafloor that have never been explored. There are underwater caves and canyons that could potentially harbor large unknown creatures. There are trenches where the deepest parts have been visited only a handful of times. Dr. Edith Witter, a deep-sea biologist who specializes in bioluminescence, points out that our exploration methods might actually be scaring away large deep-sea creatures before we can observe them. Bright lights and noisy ROVs could cause large animals to flee long before the ROV arrives in an area. That's why Witter developed a specialized camera system called the E-Jelly, a system that uses dim red light invisible to most deep-sea creatures and deploys a bioluminescent lure to attract animals. Using this stealthy approach, Witter's team was able to film the giant squid in its natural habitat for the first time in 2012. Proof that sometimes you have to change your methods to see what's really there. So, could there be creatures in the deep ocean larger than anything we've discovered so far? It's possible, though probably unlikely that anything truly enormous remains undiscovered. But the ocean is huge, and it has surprised us before. What's certain is that there are many creatures in the deep ocean that we haven't discovered yet, perhaps millions of species, most of them small and difficult to find, but each one representing a unique story of evolution and adaptation. And every one of these species is valuable, not just scientifically, but potentially practically as well. The unique adaptations that allow deep-sea fish to maintain their cell membranes under extreme pressure are being studied for potential applications in preserving biological materials. The enzymes that allow bacteria to break down complex chemicals at hydrothermal vents could be useful in industrial processes or environmental cleanup. The bioluminescent chemicals produced by deep-sea creatures are already being used in medical research and biotechnology. The study of how deep-sea organisms resist extreme pressure has led to insights about protein folding that are relevant to understanding diseases like Alzheimer's and Parkinson's. We can't predict what applications might come from studying deep-sea life, but history shows that basic scientific research often leads to practical applications that nobody anticipated. Every species we discover, every ecosystem we study, every biological process we understand, all of this expands human knowledge in ways that might benefit us in unexpected ways. This is why protecting biodiversity isn't just about preserving nature for its own sake, it's about preserving options for the future. Every species that goes extinct is a potential source of knowledge and innovation that's lost forever. And the clock is ticking. Human activities are affecting the deep ocean faster than we're learning about it. We're potentially driving species extinct before we ever discover them, destroying ecosystems before we understand how they work. Recent studies have shown that microplastics, tiny plastic particles smaller than a grain of sand, have reached even the deepest parts of the ocean. Scientists have found microplastics in the Mariana Trench, in Arctic sea ice, in deep-sea organisms everywhere they've looked. These microplastics can be ingested by deep-sea creatures, potentially blocking their digestive systems or releasing toxic chemicals as they break down. The long-term impacts are unknown, but they're potentially serious. And plastics aren't the only pollutants reaching the deep ocean. Heavy metals from industrial processes, persistent organic pollutants from agriculture, radioactive materials from nuclear accidents and weapons testing, all of these are being detected in deep-sea environments. The deep ocean was once thought to be too remote to be affected by human activities, but we now know that's not true.
Our impacts reach everywhere, and they're accumulating in systems that might not recover for thousands of years if damaged. This is why the choices we make today matter so much. The deep ocean is resilient in some ways. Life has persisted there through mass extinctions and dramatic climate changes over hundreds of millions of years. But it's also fragile, especially to rapid changes that don't give organisms time to adapt. We have an opportunity right now to study, understand, and protect the deep ocean before we damage it irreversibly. We can establish marine protected areas that preserve crucial ecosystems. We can regulate activities like deep-sea mining to minimize environmental impacts. We can reduce pollution and greenhouse gas emissions to protect deep ocean environments from climate change. But to do these things effectively, we need knowledge. We need to understand what's down there, how it works, and how it responds to human activities. This is why deep-sea research is so urgent and so important. Every expedition to the deep ocean expands our knowledge and reveals new wonders. Every new species discovered, every ecosystem studied, every mystery investigated, all of this helps us understand our planet better and make better decisions about how to protect it. And the deep ocean holds lessons that extend beyond marine biology and oceanography. It teaches us about resilience, adaptation, and the incredible creativity of evolution. It shows us that life can persist in seemingly impossible conditions. It reminds us that there's still so much to discover, even on our own planet. In an age where it sometimes feels like everything has been explored and discovered, the deep ocean stands as a reminder that there are still frontiers, still mysteries, still new worlds waiting to be explored. And unlike the frontiers of space, which require enormous resources and technology to explore, the ocean frontier is right here beneath us. It's part of our own planet, intimately connected to everything that happens on the surface. The deep ocean isn't a separate world, it's part of our world, and understanding it helps us understand ourselves and our place on this planet. So as we look toward the future of deep-sea exploration and research, what should we hope for? What should we work toward? First, we need continued investment in the technology and infrastructure needed to explore the deep ocean. We need better submersibles, more sophisticated sensors, more autonomous vehicles capable of exploring vast regions of seafloor. Second, we need more marine protected areas that preserve crucial deep-sea habitats. We need to identify areas of particular importance, biodiversity hotspots, critical breeding grounds, unique ecosystems, and protect them from destructive activities. Third, we need better international cooperation. The ocean doesn't respect national boundaries, and protecting it requires countries to work together. We need agreements that govern activities in international waters, regulations that prevent destructive practices, and mechanisms for sharing knowledge and resources. Fourth, we need more public engagement with ocean science. The ocean belongs to everyone, and everyone should have opportunities to learn about it, appreciate it, and participate in its exploration and protection. And fifth, we need a sense of wonder and curiosity about the ocean that drives us to keep exploring, keep learning, keep discovering. Because the deep ocean still holds countless mysteries, and every answer we find leads to new questions. Let me leave you with this thought. Right now, at this very moment, There are creatures swimming in the darkness of the deep ocean that no human has ever seen. There are ecosystems functioning in the abyss that we know nothing about. There are geological processes occurring on the seafloor that we don't understand. And somewhere in the depths, there might be discoveries waiting that will revolutionize our understanding of life, Earth, and our place in the universe. The colossal squid that was filmed for the first time in 2025 had been known to science for over a century, but we'd never seen one alive in its natural habitat. How many other creatures are out there that we've never seen at all? What undiscovered ecosystems might exist in unexplored trenches? What bizarre adaptations have organisms evolved in isolated undersea mountains? What mysteries are hidden in the vast regions of seafloor that have never been visited? The answers to these questions are out there, waiting in the darkness of the abyss. And every expedition, with every new technology, with every hour of effort by dedicated scientists and explorers, we get closer to understanding this incredible realm. The deep ocean is a reminder that our planet is still full of wonders, still capable of surprising us, still holding secrets that challenge us and inspire us. And you, yes, you listening to this right now, you're living in a golden age of ocean exploration. You have access to live feeds from deep-sea expeditions. You can participate in citizen science projects that contribute to actual research. You can follow discoveries as they happen in real time. The mysteries of the deep ocean aren't locked away in academic journals and research labs. They're accessible to anyone with curiosity and an internet connection. So I encourage you to explore, to learn, to ask questions, and to appreciate the incredible planet we live on. The ocean covers most of Earth's surface, contains most of Earth's living space, and holds most of Earth's biodiversity. Understanding it, protecting it, and appreciating it isn't just the job of scientists, it's something we all share in. The deep ocean, the uncharted abyss, is one of the last great frontiers on Earth. It's a realm of crushing pressure and complete darkness, of bizarre creatures and extreme ecosystems, of unexplained mysteries and ongoing discoveries. It's a place that challenges us, inspires us, and reminds us that no matter how much we learn, there's always more to discover. And that, perhaps, is the greatest gift the ocean gives us, the promise that the adventure of discovery will continue, that there will always be new wonders to find, new questions to answer, new mysteries to unravel. So, the next time you look at the ocean, remember, beneath those waves lies an alien world more mysterious than outer space, more extreme than any environment on land, more full of life than you can imagine. And we've only just begun to explore it. The abyss awaits.